In this video, I'll talk about Hess's law. Hess's law states that the change in enthalpy for a stepwise process is the sum of the enthalpy changes of all the steps, period. This is because enthalpy is a state function. The change in enthalpy of a process is simply equal to h of the final state minus h of the initial state. It does not matter if you look at just a one-step process or decompose this process into two steps or many steps. In the end, the enthalpy change of the process is simply the enthalpy of the final state minus the enthalpy of the initial state. Let's work on one example problem. So first, the enthalpy change is 600 kJ per mole for this reaction, 2A producing 2B plus C. This is an endothermic reaction because this number is positive. And then let's say enthalpy of reaction is negative 50 for this reaction. D produces A plus 1/2 of C. And this is an exothermic reaction because heat flows out of the system. Our goal is to compute the enthalpy of this reaction from 2A to B plus D. Let's look at the first two chemical reactions with known values of enthalpy change. They both contain chemical C, but in the target reaction, C disappears. So it tells us we may have to cancel C. But C appears on the right-hand side in each of these two reactions. So maybe we should just reverse this reaction to move this C to the left-hand side and then multiply all the coefficients by 2. So let's do this. First, let's reverse the direction of this reaction. We have A plus 1/2 of C appear on the left-hand side and D appear on the right-hand side. We need to change the sign of the enthalpy of the reaction from negative 50 to 50. It's not enough. We have 1/2 of C here. We have 1 C on the right-hand side. Therefore, we multiply this reaction by 2. And then we get 2A plus C reacting to produce 2D. At the same time, we need to multiply this 50 by 2. We get 100 kJ per mole. Now we have this reaction and this reaction, which have C on the right-hand side here and on the left-hand side here. And we can simply sum up these two reactions. Let's do this. The first reaction, we have 2A producing 2B plus C. The second reaction, we have 2A plus C producing 2D. So we just need to sum up these two. The left-hand side is going to be 2A plus 2A plus C here. The right-hand side is 2B plus C plus 2D here. C and C cancel. When we sum up these two reactions, we also need to sum up the enthalpy change. Now it's 600 plus 100, which is 700 for this entire reaction. This is 4A producing 2B and 2D. And then we need to take care of the coefficients by dividing each coefficient by 2. In the end, we get 2A producing B plus D. The enthalpy change is 700 divided by 2, 350 kJ per mole. I'll let you work on one practice problem here. Use the information presented here. I'll let you compute the enthalpy of reaction for D producing B plus C. So hint, A must be cancelled. You look at these two reactions. You see 2A here. You see only 1A here. Somehow you need to cancel the A's.